Good morning, all of you. In this session, I'm going to explain about a new concept that is Lamis Theorem. Okay, it is very important for a subject point of view and exam point of view. Okay, and also in this session, I will explain these two problems. Okay, by using Lamis Theorem. Okay, Lamis Theorem. This is the statement of the Lamis Theorem. It is very important. Okay, Lamis theorem states that if three coplanar concurrent forces acting at a point are in equilibrium, each force will be proportional to the sine of the angle between the other two forces. Okay, this is the statement. Now, this is the proof. Suppose the three forces P, Q, and S are acting at a common point and they are in equilibrium. Okay, hence they can be represented by the three sides of the triangle taken in the same order. Like this. Okay. So here, these are the three coplanar concurrent forces. Concurrent forces means all the forces join at a common point. Join or passing through a common point. Okay. So this is a common intersecting point. So these three are concurrent forces, coplanar concurrent forces. Okay, the line of action of all these forces lying in a single plane. Okay. So here P, Q, S are the three forces. Okay. Alpha is the angle between P and Q force, and beta is the angle between Q and S forces. Here gamma is the angle between P and S forces. Okay. So this is the given diagram. Now for Lamis proof, we need to convert this diagram into triangle. Okay. These forces can be represented by the three sides of the triangle taken in the same order. Okay, first you have to consider this line as it is. Okay, I will show you once again. I will repeat once again. Okay, first you have to consider this horizontal force P as it is. Okay, after that you have to move this Q force from here to this end. Okay, to form a triangle. Okay, now this is the alpha angle between Q and P force. So this is the same. Okay, here this is the alpha angle. This is the another remaining angle 180 minus alpha. Okay. Now you have to consider this third force as it is like this. Okay. So here this S force makes an angle beta. Okay. And the remaining angle is 180 minus beta. Okay. Now this is the angle gamma. Okay, this is angle gamma and the remaining angle is 180 minus gamma. Okay, so here I converted this given three forces into triangle. Okay, from this triangle you have to prove the Lamis theorem. Okay, now alpha equal to angle between force P and Q, and beta is the angle between force S and Q. and here gamma is the angle between force S and P. Okay. Now, now applying sine rule. Sine rule. Okay. You have to apply sine rule for this triangle. Here, after applying the sine rule, you will get this equation. Force divided by sine of the angle between opposite corner. Okay, force divided by sine of the angle between opposite corner. So here this is the force P and the opposite corner is 180 minus beta angle. Okay, and here this one is Q force, the opposite corner is 180 minus gamma. Okay, and this one is S force and the opposite angle is 180 minus alpha. Okay, so from sine rule, force divided by sine of the angle between opposite corner. Okay, so from this triangle P by sine 180 minus beta equal to Q by sine 180 minus gamma. Okay, and S divided by sine of 180 minus alpha. These all are equal and equal to constant value. Now from this equation, already we know that sine of 180 minus beta equal to sine beta, sine of 180 minus gamma equal to sine gamma, and sine of 180 minus alpha equal to sine alpha. Okay, this is the final equation. So this is the Lamis theorem equation, Lamis equation. Okay, this Lamis equation is used to determine the unknown forces. Okay, yeah, this theorem is applicable for three concurrent forces only. Three forces only. Okay, this theorem is applicable for three forces only. Okay. Before going to the example problems, first of all, you have to know the fundamentals, that is the free body diagrams. For right side direction, you have to consider positive sign. For left side direction, you have to consider minus sign. For upward action, you have to consider positive sign. For downward action, you have to consider negative sign. Okay, these are the sign conversions. Now, for solving the problems, first you have to draw free body diagram. So these are the fundamentals for drawing the free body diagram. Okay. Consider a block of weight W, which is suspended from a fixed support, means of a string. Okay, as shown here, a string is assumed to be light, okay, lightweight and inextensible. Okay, here W is the self weight of a block. Now you have to convert this diagram into free body diagram. Okay, here first of all you have to consider given diagram as it is. Now this self weight W always acts vertically downwards. So this is the direction of a force. Self weight W. Okay, self weight always acts vertically downwards. Now this is the action. From the Newton's third law, every action there is equal and opposite reaction. Okay, already we know that from Newton's third law, for every action there is equal and opposite reaction. So this is the action. Now the reaction is in opposite direction. Here the tension will develop in string. Okay, the tensile forces will develop in string. So you have to consider opposite direction force. Okay, let T is the reaction force developed in the string. Okay, now you have to consider these two forces only. Okay, so W downward direction and T is upward direction. So this is the free body diagram for this given diagram. Okay, in similar way, consider a block of weight W which is suspended from a fixed support by means of a string as shown in figure. Okay, yeah, this block is suspended by two strings from ceiling. Now you have to determine the forces induced in the string. Okay, first of all you have to convert this diagram into forces diagram. Okay, So here the self-weight W always acts vertically downwards, and this is the tension induced in the string, and this is the another tension induced in the second string. Okay, so T1 is the tensile force induced in the string, first string. T2 is the tensile force induced in the second string. Okay, so W is the action, T1 and T2 are the reactions. Okay, now you have to consider forces only for a free body diagram. Now you have to consider horizontal and vertical axis. Now you have to draw this vertical force W in downward action. After that, you have to consider this T1 and T2 tensions as this. Okay, so the angle of a string depends upon the given diagram. Okay, so this is the free body diagram for this given problem. Okay, so these all are the fundamentals for solving the problems. By using these fundamentals, you can solve any type of problem. So this is the example problem. A block of weight 100 newtons. A block of weight 100 newtons is suspended from the ceiling by a string as shown in figure. Find the tension in the string. Okay, so this is the question. So you have to determine the tensile force induced in the string. Okay, you have to determine the tension or tensile force developed in the string. First of all, you have to convert this given problem into forces diagram. So here the self-weight 100 newtons always acts vertically downwards, and this is the opposite reaction. Okay, T is the tension developed in the string. Now you have to consider these two forces for free body diagram. So this is the reference axis, horizontal axis and vertical axis. Now you have to consider this self-weight W as it is on vertical axis. After that, you have to consider this vertical force T, tension in upward direction. Okay, so this is the free body diagram. Okay, from this free body diagram, you have to determine the unknown force T. Okay, here the value of W equal to 100 newtons. Here the tension T is unknown value. So for determining this tension, you have to resolve all the forces along the vertical axis. Okay, sum of all vertical forces Fy equal to 0. Okay, the let the given diagram is in equilibrium condition. So resolve all vertical forces equal to 0. So for upward action, you have to consider positive sign. For downward action, you have to consider minus sign. So plus T minus W equal to 0. Okay. For upward action, you have to consider positive sign. For downward action, you have to consider minus sign. Okay. So plus T minus W equal to 0. So T equal to W. Here W equal to 100 So the tension or a reaction in the string T equal to 100 newtons. So this is the answer for this problem. Okay, this is a simple example problem. Now this is another example problem. A block of weight 1 kilonewtons is suspended from the ceiling by two strings as shown in figure. Okay, find the tension in each string. Here the weight of block is 1 kilonewton. 1 kilo equal to 1000. So 1000 newtons. 1000 newtons is the self weight of a block. Now you have to determine tension in each string. Okay. Here the angles are given. Okay. Now you have to convert this diagram into forces diagram. First of all, you have to consider this support horizontal ceiling. After that, you have to draw the given diagram, that is 1000 newtons block. Here the self weight of this 1000 newtons always acts vertically downwards like this. Let W is the self weight. Now tension, the tension in the string T1, the tension in the string is T1. Okay, it makes an angle 30 degrees with respect to the horizontal ceiling. and here T2 is the tension in the string, another string. Okay, so the angles are same. Okay, these are the two angles given in are already given in figure. So 30 degrees, 60 degrees. You have to consider as it is. Now you have to move these two angles with respect to horizontal axis. Already we know that opposite angles are equal. So this 30 degrees, you have to move this 30 degrees from here to here. And you have to move this 60 degrees from here to here. Okay. So opposite angles are equal. So you have to consider only forces diagram. So this is a reference horizontal vertical axis. You have to consider this vertical load W equal to 1000 newtons as it is, vertical downwards. After that, you have to consider this T1 force, tension T1. This tension T1 makes an angle 30 degrees with respect to horizontal. Now you have to consider this tension T2. Okay. Here, this tension T1 makes an angle 30 degrees with respect to horizontal line. So you have to consider 30 degrees here and 60 degrees here. Okay. So this tension T2 makes an angle 60 degrees with respect to horizontal. Okay. So this is the final free body diagram for this given problem. Okay. Now you have to solve these two forces. Okay. So here from Lamis theorem, for applying the Lamis theorem, you have to determine all angles. Okay. Here from free body diagram, the angle is 30 degrees and 60 degrees. So here the total angle between force W and T2. Here the total angle between these two forces is 90 degrees plus 60 degrees. Here you can observe the angle is here 90 degrees. Here the angle is 90 degrees. Okay, the total angle is 60 plus 90, that is equal to 150 degrees. Okay, and here the total angle is 30 degrees plus 90 degrees. So the total angle is 120 degrees. The angle between tension T1 and W is 120 degrees. Okay, 30 degrees plus 90. Okay, this is horizontal axis, this is vertical axis. So the angle is 90 degrees between horizontal and vertical line. Okay, 90 degrees plus 60 equal to 150 degrees. And here 90 degrees plus 30 degrees equal to 120 degrees. Now the remaining angle is total 180 degrees minus 60 minus 30 equal to 90 degrees. So the remaining angle is 90 degrees. Okay. Now you have to add these three angles. 120 degrees plus 150 degrees plus 90 degrees equal total angle is equal to 360 degrees. So our assumed angles are correct. Okay. Now the angle between T1 and T2 force is 90 degrees, and the angle between T1 and W force is 120 degrees, and the angle between tension T2 and self-weight W is 150 degrees. Now you have to apply Lamis theorem for getting the tensions. Okay, from Lamis theorem, force divided by sine of the angle between other two forces. Okay, force divided by sine of the angle between other two forces. Here T1 is the force. Okay, T1 divided by sine of the angle between other two forces. Here other two forces, the angle is 150 degrees. So T1 divided by sine 150 degrees, and 1000 newtons divided by sine 90 degrees, and equal to T2 divided by sine 120 degrees. Okay, this is the Lamis equation from Lamis theorem. T1 by sine 150 degrees equal to 1000 by sine 90 degrees equal to T2 by sine 120 degrees. Okay. Now for calculating the tension T1 and T2, you have to resolve these two equations and these two equations. First, you have to consider these two equations. Okay. First, you have to consider these two equations for determining the value of T1. After that, you have to consider these two equations. Okay. For determine the value of T2, for determine the value of T2, you have to consider these two equations. Okay. Now I am considering these two equations as it is. Okay. Now apply cross. Now consider cross multiplication. T1 equal to 1000 by sin 90 into sin 150. So from this equation, the tension in the string T1 equal to 500 newtons. Okay. Now you have to consider these two equations as it is. 1000 by sin 90 equal to T2 by sin 120. Here from by applying cross multiplication, the value of T2 equal to sin 120 into 1000 by sin 90. From this equation, the tension in the string T2 equal to 866 newtons. Okay, this is the final answer for this problem. Okay, very simple. Okay, very simple answer. First, you have to convert given diagram into free body diagram. Okay, after that, you have to apply Lamis theorem. Now, this is the another example problem. An electric light fixture of weight 15 newtons is suspended by two strings as shown in figure. Find the tension in each string. So this is a horizontal ceiling. This is a vertical wall. Okay. Here, these are the two strings. This one is light fixture. Okay, this light fixture is suspended by two strings as shown here, and the given angles are 45 degrees and 60 degrees. Okay, so this is the given diagram. First of all, you have to convert this given diagram into forces diagram. Okay, so first you have to consider this self weight. Here, self weight of light is 15 newtons. So the self weight of any body acts vertically downwards. So you have to consider vertically downward force, that is a self weight. After that, you have to consider tension in the string in opposite. You have to consider tension in opposite direction. Okay, this is T1 is the tension in this string, and now you have to consider this string. Let T2 is the tension in the second string. Okay. Now you have to consider these two angles as it is 45 degrees and 60 degrees. These are the two given angles. Okay. Here from this triangle, you can observe here the angle is 90 degrees. Okay. Here the angle is 90 degrees. From this triangle, you can observe this is a right angle triangle. Here the angle is 45 degrees. Here the angle is 90 degrees. The remaining angle is 45 degrees. So here the horizontal angle is 45 degrees. Okay. So here the angle is 45 degrees. Now the opposite angles are equal. So here the angle is 60 degrees. So you have to consider the opposite angle same. Okay. Now you have to consider forces only. This is the reference axis, horizontal and vertical axis. This is a self weight W equal to 15 newtons vertically downward. Now you have to consider this T1 and T2 forces as it is. After that, you have to consider horizontal angles. Here the angle is 45 degrees and 60 degrees. Okay. Now this is the final free body diagram for this problem. Now you have to consider this diagram for applying the Lamis equation. Okay. Now you have to calculate a angle between two forces. From this diagram, the angle between T2 force and W is 90 plus 60, that is 150 degrees. Okay. Now the angle between these two forces is 45 plus 90 degrees, that is 135 degrees. Now the remaining angle between T1 and T2 forces is 75 degrees. Okay. The total angle is 360 degrees. 360 degrees. 150 plus 75 plus 135 equal to 360 degrees. Okay. Now you have to apply Lamis theorem. Okay. So here the angle is angle between T1 and T2 is 75 degrees, and the angle between T1 and W is 135 degrees, and the angle between T2 force and W is 150 degrees. Okay. Now you have to apply Lamis equation. From Lamis theorem, the force divided by sine of the angle between other two forces. Okay. So here the force is T1. So the opposite angle is 150 degrees. So T1 by sine 150 degrees. And here, sorry, this weight is, this self weight is 15 newtons. Okay, this one also 15 newtons. Here the weight of light fixture is 15 newtons. So this one. Okay, this 15 newtons. This is a 15 newtons force. The opposite angle is 75 degrees. So 15 by sine 75 degrees. And the T2 force. This one is the T2 force. The opposite angle is 135 degrees. So T2 divided by sine 135 degrees. Okay. Now you have to consider these two forces. Okay. You have to consider these two forces for determining the value of T1. After that, you have to consider these two forces for determining the value of T2. Okay. Now I am considering these two forces. Okay. Apply cross multiplication. Okay. T1 equal to 15 by sine 75 into sine 150. From this equation, T1 equal to 7.76 newtons. So the tension in the string T1 equal to 7.76 newtons. Okay. In similar way, you have to consider these two equations as it is. Now apply cross multiplication. T2 equal to 15 by sine 75 into sine 135. Okay. From this equation, the tension in the string T2 equal to 10.98 newtons. So this is the final answer for this given problem. Okay. Now coming to the last problem in this session. This is a given diagram. Okay. Sorry, this is a given question. From given question, you have to calculate tension in the each string. So here a block of weight 1000 newtons is suspended from ceiling by two strings as shown here. Here the angles are not given. Okay. But here the length of each string is given. So the length of this string is 4 meters. And the length of this string is 3 meters. And the length of horizontal ceiling is 3.4 meters and 1.5 meters. Okay. So this is the length of this ceiling, and this one is the length of the string. This one is the length of the another string. Okay. By using these lengths, you have to determine the angles. So let gamma is the angle between this string and floor. Sorry, this string and ceiling. Let theta is the angle between this string and ceiling. Okay. From this diagram, first of all, you have to determine the angles theta and gamma. Okay. From this triangle, you can observe this is a right angle triangle. So this is a hypotenuse, this is a horizontal adjacent side, this is the opposite side. Okay. Here we know that hypotenuse value and adjacent side value. So you have to consider cos gamma. Cos gamma equal to adjacent side divided by hypotenuse. Here the adjacent side is 3.45 divided by hypotenuse value is 4. So cos gamma equal to 0.86. Now gamma equal to cos inverse of 0.86. So gamma equal to 30 degrees. So the angle is gamma equal to 30 degrees. Okay. Now, similarly, from this triangle, you can observe this is a right angle triangle. Okay. Here the angle is 90 degrees. So from this triangle, you can observe this is a hypotenuse. This is a horizontal side. This is a vertical side. Here you know that horizontal length and hypotenuse value. So you have to apply cos theta. Cos theta equal to adjacent side 1.5 divided by hypotenuse equal to 3. So theta equal to cos inverse of 0.5 equal to 60 degrees. Okay, these are the two angles. Now you have to convert this diagram into forces diagram. Okay. Self-weight always acts vertically downwards, and T1 is the tension opposite direction. This is the tension in the other string. Okay. So these are the two opposite forces. Okay. From Newton's third law, you have to consider from Newton's law for every action there is equal and opposite reaction. So here the action is W, and T1, T2 are the opposite reactions. So you have to consider opposite direction. Okay. Now all this one is gamma, this one is theta. Now here the angle is gamma and here the angle is theta. Opposite angles are equal. Okay. Now you have to convert this diagram into free body diagram. First you have to consider this vertical force as it is. Now you have to consider this tension T1, and after that you have to consider this tension T2. Okay. Now you have to consider this gamma equal to 30 degrees and theta equal to 60 degrees. Okay, theta equal to 60 degrees, gamma equal to 30 degrees. So this is the free body diagram for this problem. Okay. Now from this free body diagram, you have to determine the value of T1, T2. Okay. For applying the Lamis theorem, you have to determine the angle between two forces. So here the angle is 90 degrees. So 90 plus 60 equal to 150 degrees. Okay, the angle between force T2 and W is 150 degrees. Here also the angle is 90 degrees. 90 plus 30 equal to 120 degrees. That is the angle between T1 and W. Okay, 120 degrees between the tension T1 and self-weight W. And the remaining angle between for tension T1 and T2 is 90 degrees. Okay. Now you have to apply Lamis theorem for this diagram. Okay. This is the Lamis equation. Okay. Force divided by sine of the angle between other two forces. Okay. So T1 divided by opposite angle sine 150 degrees. Okay. Now W divided by opposite angle sine 90 degrees equal to T2 divided by opposite angle sine 120 degrees. Okay. So this is the Lamis equation. From this equation, first you have to consider these two equations. After that, you have to consider these two equations. Okay. Here I consider these two equations as it is. Now apply cross multiplication. From this equation, T1 equal to 1000 divided by sine 90 into sine 150 degrees. Now from this equation, the tension in the string T1 equal to 500 newtons. Okay. Now you have to consider these two equations as it is. Apply cross multiplication. Okay. From this equation, T2 equal to 866 newtons. Okay. This is the final answer for this problem. Okay. First, you have to convert given diagram into forces diagram. After that, you have to convert that forces diagram into free body diagram. Okay. After that, you have to apply Lamis theorem for determining the unknown forces in the strings. Okay. Okay. In next class, I will explain more problems on this concept. Okay.